This is the first lesson in Unit 10. We're going to look at Pythagorean theorem, which I know that you have seen before and remember from 8th grade. So the first thing we're going to look at is the actual formula, all right? So for Pythagorean theorem, we have a squared plus b squared equals c squared, right? And so what this represents, or what this talks about, is looking at a right triangle. A right triangle has a right angle. That's the little symbol for right angle. Directly across from the right angle is always going to be the hypotenuse. Okay, the letter we use is C for the hypotenuse, so that's where c squared goes. The hypotenuse we need to know is the longest side. Okay, and then the other two sides, the sides that are touching the right angle, are A and B. Doesn't matter which one is which. These are the legs of the right triangle. All right, and if we want to, there's going to be a bunch of things that we can do. We can use Pythagorean theorem to determine if a triangle is a right triangle. Hence here it says, is it? And we're also going to use Pythagorean theorem to find missing lengths. So the first we're going to look at is to see, is it a right triangle? Well, if it is a right triangle, then Pythagorean theorem, I'll abbreviate with PT, will work. Okay, if it's not a right triangle, the Pythagorean theorem will not work. So I have to see, all right, well, which of the sides that are given to me is the longest side? That would be 17. And then that would mean that A and B are the 8 and 15. It doesn't matter which order, which one's A, which one's B. It does matter which one C is. And I want to see if the Pythagorean theorem works. So I'm going to plug in 8 squared for A. B is 15 squared. And C is 17 squared. So you can either multiply these numbers by themselves to get the squared, or you can do it in a calculator. 8 squared is 64. 15 squared is 225. And 17 squared is 289. And 64 plus 225 is 289. And 289 does equal 289. Since this is true, it works, then yes, it's a right triangle. Okay, so it's just yes or no. Yes, it's a right triangle, or no, it's not a right triangle. So then looking at the next one, the longest side has to be C. That would be 25, leaving 9 and 24 to be A and B. And I'm plugging it into A squared plus B squared equals C squared. So we're going to say 9 squared plus 24 squared is equal to C. Oh, not C squared. What is C? C is 25. 9 squared is 81. Plus 24 is 576. And 25 squared is 625. 81 plus 576 is 657, which is not equal to 625. This is no, it is not a right triangle, because 657 does not equal 625. And then we're going to use Pythagorean theorem to find missing lengths. So be careful, because there's two types of problems here. Problems like A and B are the same, and problems like C and D are the same. And you will see why. For A and B, you see that the length that you're missing is C. It's the hypotenuse because it's directly across from the right angle. You're missing length, the hypotenuse. All right. The difference is here in C, you're given the hypotenuse, and in D, you're given the hypotenuse. You're missing either A or B. It's a different type of problem. So make sure you understand that there's a big, big difference here in how we solve them. We're still plugging into Pythagorean theorem, but we're going to go about solving it a little bit differently. So my a squared plus b squared equals c squared. This is c. It does not matter which one is a and b. So 24 squared plus 7 squared equals x squared. I don't know what c is. 24 squared is 576. 7 squared is 49. It equals x squared. I don't know. I'm going to add those two together. 576 and 49 is 625. But now I have x squared. I don't have x. To get rid of a squared, you need to square root. So in the calculator, if you're doing the square root, you have to click the second button and then the x squared button. I'm going to write that down. So the second button and then the x squared button, because above the x squared is the square root, okay? So second and then x squared will give us this thing, and then you type in 625, and then we get x is equal to, the square root of 625 is 25. If you don't have a calculator at home, you can also do this in Desmos. I can jump over there in just a few minutes so that you can see where to do that. So B, again, same setup because C is the unknown. So I have A and B are my other sides. 7 squared plus 5 squared equals C squared. C squared or X squared, it doesn't even matter. 49 plus 25. I don't know what C is going to be or what X is going to be yet, but I'm going to add these two. 74. And then don't forget to undo the squared. We're going to square root. Square root of 74 is 8.60, so 8.6 is my missing length. All right, and then looking at C and D to see how this is different. So we're given C, so if we're plugging into A squared, B squared, and C squared, like this is going to be my A and my B, and then I'll do this one where this is A and this is B. So it doesn't matter where X is. X doesn't have to be A, it doesn't have to be B. It's just not C here is the most important part. So I have x squared plus 5 squared equals 13 squared. 5 squared is 25. 13 squared is 169. And then I have to actually solve this. How do I get rid of a 25? I'm going to subtract it. And 169 minus 25 is 44. I still will have to square root it. X is the square root of 144, excuse me. Should have been square root of 144 is 12. And now notice, this is my leg. It should not be bigger than my hypotenuse. 12 is not bigger than 13, so this fits in my right triangle. Okay? D, 10 squared plus x squared equals 20 squared. 10 squared is 100 plus x squared. 20 squared is 400. And then you're going to take away 100. Move it to the other side by subtracting. Bring x squared down is equal to 300. We're not done until x is alone. It's not alone if there's a squared with it. The square root of 300 is 17.32, I think it is. So 2 tells 3 to stay at 3. And again, this, not that leg, is this leg right here. And it's not bigger than 20, so it fits in my right triangle. If you are going to Desmos, which I was not prepared to, but we can go ahead and do that. If we're in Desmos trying to do these things, all you need to type in is the square root of, like we said, 300. It'll give you exactly what that value is, even if you don't have a graphing calculator at home, if you didn't check one out at the Media Center. You have the option to do all of the math right in here in Desmos. All right, and that's the Pythagorean theorem.